Hi guys, in this video we're going to look at some of the factors that affect enzyme activity. We're going to talk about what enzyme activity is, then look at three of the factors that affect it: temperature, pH, and substrate concentration. So firstly, to define enzyme activity, this is looking at the speed in which an enzyme works, producing the reaction or controlling the reaction that it's controlling. So we know that enzymes work on a substrate to produce a product. So basically it's how many of those products are being produced within a specific period of time. Now, because enzymes are made of proteins, they're susceptible to changes in the body, and these changes cause them to change how efficient or their activity they are at doing their reaction. And a couple of these ones are temperature, pH, and substrate concentration. So firstly, we'll look at temperature. So when we've got a solution and that solution has a temperature, so it has some heat energy in it, as long as it's not at zero, the molecules in that, including the enzyme and the substrate, are vibrating around. The more we heat that solution, the faster they're going to vibrate. Therefore, as we increase temperature, we're going to increase the amount of collisions that occur between the enzyme and the substrate. Therefore, that enzyme is going to act on that substrate, produce the product, and increase the enzyme activity. So, at first, we see increasing temperature increase enzyme activity. However, as I said before, enzymes are proteins. So at a certain point, the heat breaks down the three-dimensional structure of the protein and melts the side chain bonds that give the protein its three-dimensional structure. And this decreases efficiency. And if we heat it too much, we're going to do what's called denature the enzyme. And this is an irreversible process that means that these enzymes no longer are the shape that they're supposed to be. If you think about like cooking an egg, once the egg is cooked and the protein has turned that white color, you can't bring it back. So this means that we've got a point of optimal temperature. So there's a point at which the temperature is warm enough that the kinetic energy is high, but cool enough that we haven't started to denature our proteins yet. So if we were to graph this, the rate of reaction or the enzyme activity compared to temperature, we see an increase up until a certain point, and that point is where that enzyme starts to denature, and then that denatures quite quickly and drops off, eventually getting to zero enzyme activity. Now we'll look at pH. pH, if you don't know, is a measure of how acidic or basic something is. Something with a low pH is very acidic. So down this end of the graph is acidic, up this end of the graph is alkaline. So enzymes, again, being proteins, respond to pH in a similar way that they respond to temperature, and in particular that higher temperature. So if it's too acidic for them, it's going to denature them, and if it's too alkaline or too basic for them, it's going to denature them as well. So therefore, each enzyme has an optimal pH where it works really well, and outside that optimal pH, it's going to decrease the enzyme activity. Now, different enzymes have that optimal pH at different points. So we've got three enzymes here: pepsin, amylase, and arginase. Now, amylase is an enzyme that's produced in saliva to break down starches. So when that amylase works, it's working at a neutral. Your saliva is neutral, pH 7. So it's active at pH 7. Pepsin, on the other hand, is an enzyme that's found in the stomach. So when it's working in the stomach, it's in the stomach acid. So its pH, or optimal pH, is lower. Arginase is an enzyme that's involved in the creation of urea through the urea pathway. And urea is slightly basic. So arginase is effective in that basic area. So depending where in the body this enzyme is found, depends on what the optimal pH for that enzyme is. Now we're going to get onto substrate concentration, and this works a little bit differently and is a little bit hard for people to get their heads around. So we'll look here at an example, and I just said that amylase breaks down starch into maltose, which is a sugar. And there's a couple of different amylases, but that's what beta amylase does. So here we've got the enzymes, and here we've got the starch molecules. So you can see that here there's lots of enzymes, not many starch molecules, so that the amount of collisions isn't going to be very many. While here we've increased, enzymes are the same, but we've increased the amount of starch molecules. So the collisions are going to occur quicker, so therefore the enzyme activity is going to increase with an increase in substrate concentration. However, eventually you get to a point where all the enzymes are bound with the substrate into an enzyme substrate complex. So there are no more enzymes to work on those substrates. And this means that adding more substrate isn't going to increase the enzyme activity at all. And we call the point at which this increase stops the saturation point, because all of the enzymes are saturated with the starch, with the substrate, in this case starch. Now this is a little bit hard for people to get their head around, so I'm just going to tell you a story. Bear with me here. So this is my brother Anthony. He works in a factory, and his job is putting the stickers on the apples. And he's been there for a couple of years, so he's pretty good at his job. He can do 3 buckets of apples in an hour. So each hour the truck comes out from the orchard, brings buckets in, they get distributed, and he can put stickers on 3 of those buckets in an hour. So if we were to write an equation for this, this would be apple plus stickers, and then the enzyme here is catalyzing this reaction is Anthony. It wouldn't happen without him, and we end up with apples with stickers on them. So the first truck comes in, and he gets half a bucket off that truck. Now, as I said, he can do 3 buckets an hour, so in that hour, before the next truck comes, he does his half a bucket, then he goes out for a smoke. The next truck comes along, and he gets 1 bucket. And as I said, he can do 3 buckets an hour. This is easy for him, so he does his bucket. Then he goes and makes himself a coffee. So he's done 1 bucket in that hour. The next truck comes in. This truck has 2 buckets for him, still within his capability, although he's working a bit harder now. So in that hour, he's able to produce 2 buckets. So we're seeing that the increase in the substrate, being the apples, increases the enzyme activity, or the amount of product being made, being the apples with stickers. The next truck comes in, and it's 3 buckets of apples, and he's working pretty hard now. This is as much as he can do. But in his hour, working diligently, he manages to make his 3 buckets. Problem is that the next truck comes in, and it's got 4 buckets on it. Now, he's beyond his limit at the moment. He can only do 3 buckets an hour. So in that hour, he's only going to produce 3 buckets. And the next truck comes along, and this one's got 5 buckets. And again, he can only do 3 buckets in an hour. So his output is still only going to be 3 buckets. So we can see that once it reaches saturation point, in this case, Anthony's can do 3 buckets. Adding more substrate doesn't increase the production. Doesn't even matter if we bring it up to 10 buckets. Adding more and more, no change. So on a graph, this looks like this. So we start firstly, as we increase that substrate concentration, we start to see a fairly steep increase. So the more substrate that comes in, the faster the reaction rate. But as this nears the saturation point, we see this number start to plateau. And eventually, if we were to go out further, this would become flat, where we reach that saturation point, and no more adding of substrate would increase the amount of activity that. In this video, we've talked about enzyme activity being how much substrate is converted into product by an enzyme in a period of time. We've talked about how temperature affects this enzyme activity, firstly increasing it because of the increase in kinetic energy, and then decreasing it because of the denaturing of the enzyme because it's a protein. We've likened this to pH, being that there is an optimal level of pH and temperature, and moving outside of these, so pH, whether higher or lower, is going to decrease that enzyme activity. And we've talked about substrate concentration, being that as you increase the substrate concentration at first, the enzyme activity increases sharply, but eventually it reaches the enzyme reaches the saturation point, where the enzyme activity stops increasing and plateaus. Thanks for watching, guys. Peace out.